All right. So we are looking at order of operations practice. We learned about it in class. We're also going to briefly touch on the distributive property, so that way we can move into our solving equations. So to practice a few of our order of operations problems here, we think about gems. So we start with our grouping symbols. So we have 16 minus a negative 2. So these two negative symbols next to each other can become positives. Everything else in the problem, I'm going to write down because I haven't used it yet. 16 plus 2 gives us 18. And I'm going to change this to a divide by 3 here. All right, we've gotten rid of our grouping symbols. Even though the 18 is still in parentheses, there's nothing we can do within those parentheses themselves. No exponents, so we move on to multiplication and division. So 5 times negative 2 gives us negative 10, plus 3 times 18 gives us, well, that's 30, 24, so it gives us 54. I'm going to carry down the divide by 3. So what I did was I did the multiplication. I'm still left with some division here, so I'm still on the M step. So we have negative 10. 54 divided by 3, it's back to 18. We're able to add these two together. 18 plus negative 10 gives us positive 8 for our answer. I'm going to skip that one. Throw some exponents in there for us. So again, we have gems we have to refer back to. Starting with our grouping symbols. So even though this negative 3 is in parentheses, that's just telling us that it's a negative. So we're going to keep the exponents for a second. Move on to the 12 plus the negative 4. So we have 8 times negative 3 squared plus 5 minus 3. 12 plus negative 4 gives us 8. And then we have divide by negative 2 cubed. Gotten rid of our grouping symbols. Onto the exponents. So negative 3 squared is positive 9. Everything else stays exactly as it is. Negative 2 cubed is negative 8, because that's negative 2 times negative 2 times negative 2. 2 times 2 times 2 is 8, and then negative, positive, negative, so that's why it stays a negative 8. Gotten rid of our exponents, so now we're on to multiplication and division. So 8 times 9 gives us 72, plus 5 minus 3 times 8, so that's negative 24 here. So 3 times 8 is the 24, we have that minus sign. And then that is going to be divided by a negative 8 here in a second. We still have the 72 plus the 5 minus, well, this is where it gets a little tricky. Do we want to include the negative with the division, or do we want to hold off and use the negative later? It's not going to change the answer, it's just going to change how we kind of write it. So for instance, if I don't include the minus sign, I just have this. So I have the 72 plus the 5 with the minus sign. 24 divided by a negative 8 gives me a negative 3. In the next stage, these two negatives form a positive. If we include the negative originally, negative 24 divided by a negative 8 is a positive 3. Notice that it's the same exact answer. This one, we just have to remember to keep both of our symbols, which can be a little bit harder, more, it's kind of the technicalities of math, those things that you just kind of have to keep track of. So either way, we're all addition, so 72 plus 5 is 77, plus 3 gives us 80. All right, one of the big ones, especially when we're talking about order of operations, is when we have fraction, stuff on the top, stuff on the bottom. So Bob and Todd here are disagreeing about the solution. Bob's work versus Todd's work. So Bob is saying that he did the grouping symbols first. So did Todd. So the first step is the exact same. The next stage, Bob squared the 4, got the 16. So did Todd. Bob also did 8 minus 4 and got 4. He simplified this fraction down to a 4. Todd did the exponents. Then, following Gems, he did division. So he divided the 16 by the 4. He guessed he could have done the 16 divided by the 8. He chose the 4. That gave us 4 over 8 and got 1/2. The problem lies over here in Todd's work. Even though he's trying to follow Gems by doing the division, when you divide 16 in this 4, technically, well, he broke a lot of rules. Let's not try to sugarcoat anything. He broke pretty much every rule in the mathematical playbook here by just doing this. 1, you divide it, this should still stay a 1 if this was even closely allowed. It's not. If you have 16 over 4 like Bob, it's technically 4 over 1. We don't have to write the 1. In this case, you would, because you'd have to have 8 minus 1 left over. So that's one issue. The other issue is with fractions, each part of it, the top and the bottom, are considered separate entities. They both have to be as simple as possible before you can make it happen. The big thing that's the reason for that are pluses and minuses don't behave nicely within fractions. So you want to get rid of them before you can do some of the operations that we know about. So Bob did the work correctly because technically there should be parentheses around this. So he can do the exponents because technically that's also in its own set of parentheses. So that stage is fine. He then did that one. Now he only has division and he can divide it. So when we have a fraction, you need to think of the top and the bottom as completely separate entities that you have to kind of work through as you go. So we have our distributive property. Talked about that last year in 7th grade, which is kind of more of a review here. With our distributive property, there's a lot of different ways. This is kind of a lot of information thrown at you. It's saying if I have a number or variable that's multiplying something in parentheses, I'm allowed to multiply each thing inside the parentheses separately. So A times B, A times C. It works if we're multiplying on the other side. Very rarely will you see it multiplying on the right. It's still technically allowed. And it doesn't matter if there is a minus sign either. That minus sign kind of goes through it because a positive times a negative stays a negative. It holds true for almost any size parentheses. So A here would multiply literally everything inside the parentheses until you got to that other side. So if we have 5 multiplying our n minus 7, 5 is going to multiply the n, and it also multiplies the negative 7, so 5 times n gives us 5n. This positive 5 times the negative 7 gives us a negative 35. Because this term has an n, they are not like terms. We cannot simplify this further. We end right here. There are no equal signs anywhere in this problem, so you do not add an equal sign. You cannot solve this problem. You can't be like, all right, I have a 5n and this negative 35. I'm going to divide by 5 like this, and now it's n equals negative 7. Where the heck did this negative symbol or this equal sign come from? If it's not there to begin with, you can't add it, so don't do that. Same thing. The negative 2 here. I distribute it. Negative 2 times 8 is negative 16. Negative 2 times positive n is negative 2n. We should rewrite this to have our variable go first. It's kind of mathematical grammar to have your largest power of your variable first, followed by the next power to the next power, ending with your constant term. So if there's more than 1, same thing, everybody's going to get multiplied. We have negative 6r, positive 24s, positive 6t. And when there are multiple variables, you list them from largest power to smallest power, alphabetical order. like this. So let's skip to one. Let's say we have a fraction like this, 3/4. The 3, since it's on the top, is going to multiply, while the 4 on the bottom is actually going to divide everybody. So you can kind of go through. I actually like to start with the number on the bottom because it makes the numbers large or smaller. Because if I start with the 3 times 8 gives me 24, and then 3 times 24 gives me, what is that, 60, 72. And then I have to divide both of those numbers by 4. It's not terrible. But if you start with the division first, eight divided by 4 is 2. 24 divided by 4 is 6, and in this case it's the negative. Multiplying these two numbers is a lot nicer than trying to divide those large ones. So 3 times the 2 gives us 6x. 3 times the negative 6 gives us negative 18. So we multiply the top number and we divide by the bottom number. So terms, a number, variable, or product of numbers and variables. So that's one term, one term, one term. This technically is 2 terms. So it's separated by the plus or minus signs. When we're talking about combining like terms, not only do you have to have the exact same letter, they also have to have the exact same power. So in this case, they're both x to the 1. We're allowed to combine them. 15 and 18 are 33. X. It's a lot like saying I have 15 cookies. I'm going to put 18 cookies with it. I still have 33 cookies. All right. These terms, this one has n, so does this one and this one. But since these are squareds and this one is not, only these two terms are allowed to be combined in this case. So I have 12n squared plus 10n. Again, you should write it biggest power of the variable to the smallest power of the variable. So we'll throw a distributive property in there with it. So that's a y squared there. I don't think I can move myself. Let's leave it up there. So it's a 2. It's a little hard to see. So first thing you're going to do, distribute. Get rid of those parentheses. That gives us 6y minus 15y squared. I know it's out of order right now. We're going to correct it later. 2 times 7 gives us positive 14y, and then 2 times the y squared gives us 2y squared. I can put together the y squared, so I have negative 15 of them here and a positive, so that's negative 13y squared. Positive 6, positive 14, for a positive 20y. The thing to be careful of with a distributive property is when you have a problem, say like this, 5x minus 3, parentheses, 2x plus 2. We want to distribute this 3, but we also have to distribute the sign directly in front of that number. In the previous example, that's a positive 2. Positives are a lot nicer than negatives. Positive 2, so everything kind of was whatever. In this problem, that's a negative, so it's 5x minus 6x minus 6. What a common mistake happens with our distributive property is we forget to distribute this negative, and so we get 3 times 2x, 6x. 3 times 2 gives us positive 6, and we just carry this negative down to where it is. But this is a completely different problem. It needs to be a minus and a minus, so we need to distribute that negative symbol. Combine our like terms, we get negative 1x. You are just allowed to write negative x, it's fine, you don't need the 1, minus 6. So either of these would be acceptable answers.